One of the reasons why it's really important to measure the colligative property of a solution is that we can use it to determine the molar mass of a solute. So the molar mass of a solute can be determined by dissolving a known mass of a solute in a given volume of solvent and then observing the effect on one of the colligative properties. This procedure works the best for non-electrolytes, that is, not for ionic compounds, because then we know that I equals 1, and so that doesn't complicate our calculations. So a typical scenario might be to take a material, dissolve it in a known volume of liquid, check whether it conducts. If it doesn't conduct, we know that I equals 1, and then measure one of the colligative properties. The colligative property that we measure is most commonly either boiling point elevation, freezing point depression, or osmotic pressure. So I'm going to give examples of how we can use osmotic pressure to determine the molar mass of a solute, and also how we could use either boiling point elevation or freezing point depression to do this. So there's really only two types of calculations that you need to be able to perform. So here's our first example where we're going to be using the freezing point depression to figure out the molar mass of a solute. So the question says 100 milligrams of the non-electrolyte, so that's just code for I equals 1, eicosene was dissolved in 1 gram of benzene. So they're giving you the mass of the solvent here. After it talks about benzene, it gives you the Kf. So we know we're going to be talking about freezing point depression. Okay. Then it says the freezing point of this solution was 1.75 degrees C lower than for pure benzene. So that is the change in the freezing point. Okay. And then finally it asks what is the molar mass of eicosene. So the change in the frequency in the freezing point is going to be equal to the freezing point depression constant multiplied by the molality. So I can reorganize that and solve for the molality. So the molality of my solution was 0.357 molar. Now I know that that the molality is equal to the moles of solute times by the kilograms of solvent, or alternatively, molality times by my kilograms of solvent is equal to my moles of solute. So I'm going to go ahead and calculate how many moles of eicosene were dissolved in this solution. So I had 0.357 moles of eicosene for every 1 kilogram of benzene, and I was told that I had 1 gram of benzene. So I need to convert that to kilograms by dividing by 1,000. So now I'm figuring out how many moles of eicosene I have. To calculate the molar mass of a substance, I need two things. The molar mass is the mass over the number of moles, and sure enough, I have my number of grams of my substance there. It was 100 milligrams or 0.1 grams. So I've got 0.1 grams of eicosene, and that is equivalent to 3.57 by 10 to the minus 4 moles. So 0.1 divided by 3.57 by 10 to the minus 4 tells me that the molar mass of eicosene is 280 grams per mole. You need to be able to do this. So the good news is that they're all done the same way, so you just got to practice a couple and make sure you get your procedure down correctly. The other type of calculation that we'll be doing when we're trying to calculate the molar mass of the solute is we'll be looking at how the osmotic pressure is affected by the presence of the solute. So if I've got 47 milligrams of a non-electrolyte, remember that's just telling me that I equals 1, dissolved in water to give 2.5 milliliters of solution. Okay, the temperature is 25 degrees Celsius. The osmotic pressure of the solution was 0.489 atm. What is the molar mass of the compound? So it's a little bit not unclear, but when they don't mention a second solution, you will assume that the osmotic pressure is against pure solvent. So the osmotic pressure is equal to MRT. where m is the molarity. So the molarity of our solution is equal to the osmotic pressure divided by RT. So we get our molarity here. So it is 2 by 10 to the minus 2 moles per liter. Now molarity is equal to our moles divided by our liters. And we were told that we had 2.5 milliliters of solution. So we can reorganize this. Our number of moles is equal to our molarity times by our volume. And so our molarity, we just solved for that, was 2 by 10 to the minus 2 moles per liter. And then our volume, that was given in the question, 2.5 by 10 to the minus 3 liters. So our sample of ecosine in this case was comprised 5 by 10 to the minus 5 moles. Once more, the molar mass is just computed by taking the grams of solute and dividing by the moles of solute. So we were told that we had 47 milligrams, or 47 by 10 to the minus 3 grams. And then we've just computed that we had 5 by 10 to the minus 5 moles. So put that into my calculator and I ended up getting 940 grams per mole. Now I just kind of like invented this, so don't worry about that. They both have the same name. Okay, so really that's the two types of problems that you need to be able to do. Either given a boiling point elevation or a freezing point depression, work out the molar mass of your solute, or alternatively, being given the osmotic pressure, be able to determine the molar mass of your compound. And again, I've got to stress, you need to be able to do this. So practice, make certain that you can do either of those two types of calculations, otherwise you're going to have a bad day on your test. Okay, on Wednesday I'll go through a handful of these with you during the Zoom session.